Hey, it's Miss Clark again. This is topic 3, sketching quadratics in vertex form, part 1b. So I'm going to briefly go over, before we went over, Hey, this is Miss Clark again. This is topic 3, Hey, this is Miss Clark again. This is topic 3, sketching quadratic functions in vertex form, part 1b. Last time we went over looking at an equation and turning it into a graph, and now we're going to be looking at the graph and translating that into a function in vertex form. So over here on the left, I've got my graph of my quadratic function, a nice parabola, and what I want to do is I want to find all three parts of this. So I want to find my a value, I want to find my h value, and I want to find my k value, and then I'm going to plug those back into the equation. So I always like to start with the vertex. I think that's a nice, good starting point for any graph of a parabola. And if I look at my vertex, I can see I'm at the point -1, 4. So this is going to be my hk, where my x is my h value, and my y is my k value. So this is my h, k. So all we have to do now is find my a value. So I'm going to go back to that vertex, and I want to see how much my parabola is being stretched. So I'm going to go from my vertex to my next intersection point and see how far up I'm going. And so if I count this, I can see I'm going up 2 and over 1, which means I'm going to have an a value of 2. And since this is a parabola facing upward, we know that 2 is going to be positive. So I'm just going to go back and I'm going to plug that into my equation. So I have y equals a, so that's 2, x minus h, which is -1, squared, plus k, which is 4. And then this minus -1 here is going to reduce to +1, so my final answer is going to be y equals 2 times x plus 1 squared. Sorry, this should be 4, because my k is 4, plus 4. And you can see from what we did last time that my h value in here is the opposite of my point, and my k value here is the same as my point. Let's do one more example, and then we're going to do a word problem. All right, so down here I've got this funky little parabola. So again, I'm going to start with just my base vertex form, so I know what points to look for. So I've got y equals a times x minus h squared plus k. I'm going to start with my vertex, which is going to be at this nice, lovely point, 2, -3. This is my h. That's my k. And then my movement from my vertex to my next two intersection points is I'm going down 1 and then over 1. So that means my a is just going to be 1. And since this is a parabola facing down, that's going to be a -1. Then I plug those in. Y equals my a, -1, times x minus my h, which is 2, squared, plus -3. This turns into -3. I can just sort of drop my 1, and my final answer is y equals -x minus 2 squared minus 3. So now I'm going to go down to a word problem. And given what we've been doing, I think the instinct here is to graph this equation. So it says a tennis ball is hit into the air. Its height y can be modeled by y equals -x minus 3 squared plus 12, where x is the horizontal position in feet and y is the height in feet. So I have 3 questions I want to answer. What is the maximum height reached by the tennis ball? What is the horizontal position when the maximum height is reached? And what height in feet will the ball reach when the horizontal position is equal to 6? So I'm gonna try to graph this, and we'll see why graphing is probably not the best way to approach this. So I'm just gonna, let's see, I wonder if I can fit the whole thing here. 2, 3, 4, 5, 6, 7, 8. Yeah, we should be good. And we're gonna go here, have a nice horizontal line. I already have an idea of what my graph looks like, so I am making it a little bit, actually maybe I'll make this part bigger, just a tiny bit. Alright, so I'm graphing. My vertex is going to be at the opposite of my h and my k, so it's going to be at 3, 12. So my vertex is at 3, 12. So I'm going to go over 3 and then up 3, 6, 9, 12 to this point right here. And then my a value is -1, so I'm going to go down 1 and over 1, down 1 and over 1, and then try and make a parabola out of this. That was a terrible line. Let me try that again. Alright, something like that. Now, we could probably answer the first two questions from this, but if we go to the third question, it says, what is the height in feet? What height in feet will the ball reach when the horizontal position is x equals 6? And you can see just from my really poorly drawn graph that at x equals 6, I have a very negative value. And so that's probably not accurate. And we can see that because we're only using 3 points, that the graphs that we create are not super accurate, and they're not really a great way to find different points on a line. So we're actually just going to use our equation to solve this. It's going to make everything a little bit easier for us. So the first question is, what is the maximum height reached by the tennis ball? This is going to be the highest point of our parabola, which is going to be always, if we have a downward facing parabola, is always going to be the vertex. And it's asking for the maximum height, so that's going to be my y value of my vertex. So that's going to be 12. So my max height is going to be 12 feet. And then it says, what is the horizontal position when the maximum height is reached? Well, my horizontal position at my vertex is going to be my x value. So my horizontal position is just going to be 3 feet. And then last question, it says, what height in feet will the ball reach when the horizontal position is at x equals 6? Now I'm going to use substitution, and I'm going to go into my equation, and I'm going to replace x with 6. Sorry, I just wanted to erase some of that junk on there. So I'm going to go into my equation, and I'm going to say y equals -6 minus 3 squared plus 12. Where I just took this x and this 6 and I replaced the x with my 6. And then I'm just going to simplify this down, and so I'm going to do the inside of the parentheses first. This is 3, and then I'm going to square that. 3 squared is 9, so y is -9 plus 12. So that means that my vertical position when I'm at a horizontal position of 6 feet is going to be 3 feet. Tune in for part 3 of the video, and we'll go over substitution and elimination.